So one thing that in the slides also I have this robot tools, or I mean the gripper. Gripper we can also have it, and this we can have it in this. We always, if you would like to work on or add something, want to edit something, please reset the simulation and then start working on. Otherwise, sometimes it's got freeze. Yeah, so you cannot do anything but just reset the simulations, and then we go to the models by type, again robot tools, and then again visual components and generic 3-jaw gripper, and then we put it to, then this gripper is small. Okay, then I have it in the 3D world. I bring it closer to this tip of this robot and plug in. If I run the simulation, so it should work, but now with the gripper. This is how simple it is, if you know, but let's, okay. So we have done this exercise. If you miss something also, I think you can find out on the slides what I use it in this exercise, and what we needed to have it like for connections and so on. Product must be defined from conveyor, lathe machine to conveyor. Now the next task we need to do, or I hope you can find out by yourself, or let's do by yourself. Have this human dummy. So there are a couple of them that you can find in PM resources. One is called Anna, another is Otto. So we either you can help, you can have Anna or Otto to help you to do this task, and then try to connect it. Meanwhile, we can have also, let's say, 5-10 minutes break, and then we continue after that. Yeah, meanwhile I can take the questions also, but yeah, right now there is a 10 minutes break. How is with you guys? Okay? Yeah. Somebody raise hand in the back now. Okay. Okay, then yeah. Okay, then the next thing, as I said, that we work on this replacement of the robot with this Anna or Otto. Any of them you can use it and try to connect it. But there is one thing we need to also do. We must have this controller, otherwise Anna or Otto, yeah, they don't want to work without the controller. There is some controller needed. So that's why we must have different controller, not the robot controller, but the human transport controller. We need it, and then we need to connect them also, so that they have some communication going on, so that in that sense they work happily, I hope. But okay, this is if you done it by yourself, otherwise I will go through. But let's finish a couple of slides more about the installation. As I said that there could be a possibility that we will have some students temporary license key. If we will have it, we will provide you. If we will not have it, you try your luck, register on their web page and ask them to give you. But we are using, and how you can install it and from where you can find it. This is also in the slides. There is a link. You need to go to the downloads. There is a download installer, and we are using Visual Components Premium 4.8. There are Essential Professional also, but we are using the premium version. So yeah, it's better one. It has all functionalities, and also you need to check the requirements of your PCs. It's better to check it before installation. Otherwise, for the keys, they give one-time key. So if I use it and computer have some problem and you need to do reinstallation, it means key is invalid. So that's a thing. But anyway, how to install it, what to download it is in the slide, and then how you need to do it. So for the, if you have the key, then you choose this option, and internet is good to have it so that you have some models that could be downloaded online, could be also there. But who are the Mac user is not the good news for the iOS operating system, or that is not compatible with that. It's only supported Windows operating system. So that is one of the thing also right now. So that's for this part of the lecture. We will continue with the visual components. Yeah, any question? Come on, yes.
Where do we get the key?
I don't know yet. Yeah, I request them to send, but usually, as I said, the previous year we got it in advance, but right now I'm not sure. But yeah, computer class is available. I hope you gonna attend it regularly and try to do the things over here. Virtual machine, something, or remote desktop is not working with this.
We use it for Siemens.
Try to connect then. I'm not sure. We need to talk with this Iger. Actually, this how the virtual machine and this remote desktop thing is working through VPN. So try it also. Let me know if it's working. We try to also figure it out. For that, so you just access that particular software, or you can access everything here. Oh, okay. Because I know with this ERP also, this in Microsoft Dynamics, during we also providing remote desktop and student can access. But for this I discussed there, I don't know, there was some complication, another thing. Previous year, I hope that I will have a key and we've distributed temporary keys, it's going to be okay. Otherwise also you can write them to have it. Let's see. I hope at least we will have when you have, as you're going to start your group work. So right now it's just a practice and we continue with those practices. You don't need to submit any exercise. So. Okay, any other thing? So have you managed to include Anna or Otto? Yes. Okay, I can show you also, then perhaps it will answer a few questions that are around. So let's see. So also I would say that if you have this first model ready, try to save it. Save as, yes. And keep it with you. Perhaps later we need in some KPIs thing. So, but if you save it, it's okay. Otherwise, I'm just let's say try to delete those things. And also, I'm deleting this robot. Now, since we are working in this PM, so everything we just try to find out from there, especially the feeder also, and then the PM resource, visual components, and then we have Anna and we have Otto. You see, so if I let's say have Otto here, then he's looking so straight, look good. So let's move Otto towards machine so that he can see the machine is 90 degrees from here. Okay, good. But So let's make connection again, or if you have connection already is good. So, but it should be. Okay, now we need the controller. As I said that dummy will not move it by him or herself, so we go to PM transport controller, and we have this one, human transport controller, and we have it, and let's put it next to this machine, and same way we try to, if we try to implement this thing on the flow lines. Right now again is going to interpolate, so again I click this controller, especially this sign, and then right click it to the flow line, change it to this implementer as a human transport controller, and then let's play again and see if auto is happy to work or not. So if it still is not working, it means some problems are around. So it means that what I have it in my last slide here, this thing is missing. So if it's not working, then we go to the home tab. Here are the interface. So I select, let's say, the controller, click on the interfaces. So there are two, let's say, tags or balloons are popped up. Then resource one, first one, connect with this PM resource. First one, resource one to this PM resource. Unselected, let's try. If it is connected, so you see the costume, the color of the dress of auto also change as the color of this controller. It means it is connected. Then we play the simulation and let's see, oh, auto start working. So yeah, so this is how it's doing with this replacement. So how the automated one and the human we can differentiate in this way. Is taking beautifully and put it back. So again, have you managed with this worker or human dummy? Yeah, is still have. One more thing, you see there is too big queue right now. If I, and this auto is a bit slow or not that fast, so I can change it, the inter-arrival time. Right now the feeder, actually if select the feeder, there are the properties over here. And in the properties, the input rate, the input to give this part from the feeder, I can change it. So if I go to the properties, default, not in the default, their product creator, and you see the interval is 5 seconds. So after every 5 second part is coming in, this inter-arrival time I can, let's say, change it to 25. So that we don't have that big queue or this bunch of cylindrical here. So the next one, it comes up after even 25 minutes. So now that's 25, so the other is coming. So yeah, okay. Systems, another thing Vladimir perhaps talk about. Okay, for the visual components, if you have done it, at least I hope first one, then try to save it and keep it with you, second one also. And now I think you, at least you have the idea that how it's working, so we will continue in the same way with the next, let's say, make it little bit bigger model, which is flexible manufacturing system. So in this, let's say in the part 2, I have slides, I will talk about what is flexible manufacturing system. Also, I will go through what are the key KPIs, key performance indicators, and what they use for. I hope you know, because yeah, master students, and I think at least you have little bit idea about. Anyway, what is flexible manufacturing system? There is some typical definition is here, some classical one, and we even got a chance to visit one of the producer of the flexible manufacturing system or flexible lines. It was in up north in Finland, even in Seinäjoki area, where we had one project with this Applied Science University there. So it's called Prima Power, which are actually providing this solution and different. But what is the flexible manufacturing system? Actually, what are the components are there? So flexible manufacturing system usually consists of computer numeric control, let's say CNC machine tools interconnected with automated material handling and control through integrated computer system. So it means that everything's are automated from starting from the raw material, or let's say buffer of input material, then go to the production area with the conveyors, some processing going on, and then after that it goes to the storage rack also automatically. That is whole system. It's working with just let's say one computer control or some software. What they are capable of, and why they call flexible, because they can produce variety of product families. So if I have a cylindrical shape and then I move to the another batch of production, which is, let's say, different shapes are there, so the setup change or the changeover is quite fast. And so different product families with the help of CNC machine tool can be tackled, and where the loading and unloading can be done through industrial robots. So what are the other characteristics they have it? So first of all, they are, I would say, highly automated production systems, capable of processing variety of different product families. Again, so in one detail I have, let's say, simple one, then the other batch of production I have complex detail, but the flexible manufacturing system are able to do with those changeover, or there is a possibility to do this changeover quick, less, let's say, manpower or working hours needed to do. And what components they usually have it? So usually they have okay, some laser cutter also, or shaping machines another, but here we can also say that they could have CNC machine tools, they can which can be used for milling, turning, or drilling purpose. Then the main thing, this ASRS, which is called automated storage and retrieval system. So that which is one of the material handling equipment. So the storage and everything is executed automatically with the conveyors movement, and we can use even robots there for loading and unloading as a machine tending, and definitely the controllers are needed to control all the things. Maybe have you seen this Festo system we have, which we also proudly present as a flexible manufacturing system in our demo center, which is Festo system for research purpose. Have you seen that one? As of working, I mean, it's moving and running. You just, Vladimir said that he is arranging some visit. Okay, someday we go and see how does it work, although it's now quite old. I mean, still working good, but we have it for a long time. So here the idea also, it has Festo quite strict back-end system, so customization is quite annoying, I would say. Anyway, we have the F system software application running on. I go to this user interface planning. I need 4 parts. I just push the button and then it start working. This is the storage area here. There are some boxes. It gives in this loading station, box is out, and then we have Robotino, is a mobile robot, goes there, pick the box, move to this machine tending area where we have small robot here, and there is small turning machine back over here. Robotino bring the part or the box which has, let's say, cylindrical parts inside, bring it to machine tending station, Then here it's move further, go to this area where robot pick it and place into the machine, machining time, machining completed, take it out, then in the other box it will put it, or the same box, and the box move in the other side and bring it back, and robot get the signal again, okay, now the box is ready with the sensor, definitely there are quite many there, and with the controller it get the signal, it goes there and bring it back here. So this is, you see the components are there, we have storage area which is work also automatically, so there is less human intervention there, so interaction of the human are quite less, everything is working, let's say, highly automated. So yeah, such kind of things, so storage and also the movement of the product is also automated, there is not manual thing. This model is created also visual components. Those who did it, the visual components use it before. I introduced such kind of layout for flexible manufacturing system. However, it's not valid anymore because previous libraries in the visual components are removed, and we don't have such kind of, let's say, ASRS systems over there. So we need to do something else, or the one that we start to do something with the PM library that we use it for machine tending. But this is also a system that we have racks, products coming from the feeder, move it, maybe I have, okay, yeah, okay, there is the video, it reflects that how the things are. So we try to create this model or execute, let's say, the process of flexible manufacturing system. So there is an input rack, there are cranes that are products coming, it is storing there, since the production is empty, so it's as it retrieve it, it fetch it into the production area, is do some processing, take it out, and then go to the another machine, and after that it will store, let's say, ready product in this in the second rack. There is a possibility to change the shapes also, like after first machining the shape is changed of the product, and after second one also, so that we will do also during our exercise. Okay, I think. So you see this person is just here, look busy, do nothing, so it's just there to just to, let's say, we pretend it's monitoring to but it's how the whole flexible manufacturing system concept is visualize and simulate. Okay, next I will little bit go through about the KPIs. I hope you know the KPIs, what KPI means, what is key performance indicators, and what purpose they are used for, because for evaluation, for assessment of any process of any system, we have different kind of KPIs. And for production systems also we use different KPIs for the analysis of our production system, how good it is, either our demands are fulfilling or not, capacity, how much capacity we have, and so on. I mean the performance parameters, or let's say those parameters we using to check our health also, like if I am healthy or not, I see my fever, yeah, if my blood pressure, yeah, such. So that also, I mean, some indicators that either the things are working good or not. So these are just example, but in the production system, what are the usual one that we use it? I have few of them here, but what they are. So KPIs are eventually like the drive the performance evaluation of production system. So if I would like to evaluate the performance of my production system, I set up some KPIs. Anyway, there must be some input data I need it, and based on that I can see that, okay, is it working at the full capacity or not, the speeds and other are okay or not, and so on. What they can do it. And so performance indicator do not just express what has happened, they will say what will happen. So with the help of KPIs, you can predict the future also, like in the simulation. So it is not about that what is happening right now. If I run my production in that speed for that long, how much I will have it. So you have good prediction of your, let's say, for the future production. And what else? The role of production performance indicator is to reflect the current state, okay, what is going on, and also they help that what can be in future, and main thing is to for monitoring purpose they use, and you can find out operational efficiency and measure the effectiveness, especially people are or companies are measuring or let's say figuring out the overall equipment effectiveness, OEE. I think you know that is the one of the case that usually we use it, where we have 3 different parameters. Actually, I have slide for that. So yeah, but mostly cited indicators to evaluate the performance of production system are this quality, cost, and the time. So this the triangle: quality, cost, and the time, and others are the derivatives from there. Cost, different kind of cost, direct cost, indirect cost, what else? Time, cycle time, I don't know, lead time, any other activity time. Quality is like definitely you need to measure it, either you are producing good quality part or bad quality parts. What is your yield? I mean the first pass yield, that either you producing good product in the first run or you have some problems, and how you maintaining. So rejections are, I mean nobody wants it, and these are the waste. In the lean manufacturing also tells that what are the lean waste. So one of these rejections are quite much highlighted there, like you don't want inventories in your production area. So anyway, okay, and for the KPIs also, they are, as I said, that it's actually quite the big topic, or actually I would say it's a big umbrella where we have different levels. Like for the operational level, we have, let's say, different KPIs or performance parameter that we collecting, let's say from the production floor, for the machines and other. Then we have tactical one, which is like the, let's say, sub processes. We have maybe some production planning parameters or KPIs that we would like to have, and the enterprise level, or let's say the supply chain level, there are different KPIs are, let's say, highlighted or needed to evaluate the performance of the supply chain. So there it can be at the different stages or different level of whole enterprise, or let's say whole business process. So this is one of the model that if I have a performance evaluation for something, the model is took from SCORE. Supply chain operational reference model is called, where we have starting with the upper level attributes, how I can find out or calculate the reliability, responsiveness, agility, cost, and asset efficiency. For reliability and responsiveness, I need to go to order fulfillment cycle time, and how it can be calculated. So this is the level 1, but it must be connected, or it should be connected to the other level. Let's say this the shop floor level we have. So the second one level is how the reliability can be divided into 3 other kind of KPIs. So we have deliver to commit date, order deliver, exact quantity, and so on. And the responsiveness is connected with the cycle time, production cycle time, delivery cycle time. So it's also connected with logistic part. However, if I would like to have some kind of planning of the timings in the production line, I need to do some kind of also that where I gonna collect some data. So good data is also one of the thing, or this important thing that we should know. If we collecting, how you collect the data first, I go with the stopwatch in the production line and start calculating. Then the production guy looking at me, oh, what is that guy doing? So maybe annoyed for them. So we move out, we put sensors now, collecting data sensors. Still maybe they can manipulate something over there, but anyway, what I'm saying, that data collection must be good and must be authentic, so that in the end you can come up with the good results and make the good decision in the end. So, but where to collect the data and how to collect the data is here is, let's say, one example we have with some kind of different activities are going on in the line. We have storage of the parts, we have drilling process, we have assembly process, we have inspection process. And we can divide this line with different timings also, and also with the numbers of the parts that we producing. So there is a table. So PT is, we have this processing time. Then we also need to keep in mind the queue time, like idle time also should be taken into the account. So how I calculate this process time, and then what is the difference that I have it with the, let's say, the queue time or the waiting time, that must be separated and analyzed separately also. Then we have okay, finished parts, rejected part, which is connected with this inventories or also work in process. So such kind of breakup we can make it. So we need the process mapping for that purpose. So map up the process, and then where to collect the data and what is what processing time, queuing time, and this also the finished goods that we producing and the rejected parts. So that is the level that we have it. Again, here are some classification that how the categories of the KPIs can be seen, because again, if I would like to evaluate some production line, I must know my goal, that what I would like to do. Either I'm just working on the capacity, or I would like to increase the throughput, or I'm just working on the quality of the product. So we need to go through different matrices: productivity, quality, financial, flexibility, but in the end we need to select few of them so that we can just focus on one area, improve it, and then move to the next. So the idea here that KPIs are not just for manufacturing thing, it can be connected with whole society and whole company. But here we focus a bit on the manufacturing unit, and let's say productivity and the quality one that we used. You see, if I just having one production line here also, quite much thing that that I could have it as a KPIs. So they can be divided into different categories. So these are the measuring one. Measuring one is the one I need some instrument to measure those KPIs or the indicators. Some are defined one, which are like the maximum speed, which is from manufacturers. Manufacturers say that okay, the spindle speed of this machine is 1000 RPM. You cannot go beyond that. So these are the defined one, let's say. I'm running my production, let's say, for, I don't know, 800 RPM. So how I can measure it, this I can measure it with different instrument. Again, first thing you can use time and motion steady, go with the stopwatch in the production and measure it, or with the sensors now you can measure. So there are measures one that you measure it, some of them defined one which are more idealistic one, and then finally we have some which are calculated ones. So there we must have some formula or equation behind it. And one of them is this OEE. So if we have, I would like to have, let's say, overall equipment effectiveness of my production line, or let's say the production cell, then I should have such kind of parameters to be measured to go have this overall equipment effectiveness, which is consist of availability factor, performance, and quality. Quality means that how much I'm producing good quality products or the bad quality products. Performance means the speed what is the throughput, and the availability means that the idleness, the breakdown, is there any breakdown in the machine or the production system, how much it's idle, how much is available for the working. Such things we can calculate it if we have such kind of let's say parameter, let's say the processing time, idle time, lead time, breakdown or failure, finished goods, rejected part, work in process. So based on that we can calculate it what I have. Okay, good. So this is one of the example that again it was one of the FASTO system, but not here, it was in Finland. We try to collect the data and try to monitor or have this info panel where we have overall equipment effectiveness. I think many companies are providing now these solutions to monitor overall equipment effectiveness. There are different software available, but anyway, you must know what is the back end there, where to collect what data. So if I'm not collecting the rejection data of my product, then I don't have this quality factor, and it's always 100%, like here right now. So, but anyway, it could be 100%. But so it's a front end. It's design. Also, application is called IoT ticket. We make this front end that what parameters we needed. So we have different parameters over here: cycle time, idle time, bottleneck processing time, and so on. Then 3 other factors. Again, back-end data model was different that we develop, and we fetch the data from the database of this because of course this FASTO system, they have their databases, although it was little bit shitty one. It was Microsoft Access. So it was just timestamps are coming, but then we need to create some SQL queries and make it the data useful. We did it a bit, and then I think this is some simulation. No? Okay, yeah. So we create this front end and we push the data, and it can be real time. So if the production is going on and system is running, then it gives some let's say the collecting data and giving the KPIs values, and you can have say that what is going on, what is the runtime, different dashboards we can even create it for energy consumption or for this throughputs and other, and then in the end we can even have those values of availability, performance and quality, and then it's a simple multiplication of that is the OEE. So I mean such kind of example is from the real production system, but in the virtual one we also do it. So statistics charts we're going to create what we have done it. Let's say for machine tending we can create some kind of statistics chart that how much I'm producing in half an hour, in 1 hour, and what is, let's say, the utilization of my asset or equipment there. So good. Okay, so the next exercise we move it again to visual components, which is connected with the flexible manufacturing system. So before moving to the visual component, do you have any question, comments? Shall we move? Okay, then with the visual components, we're gonna, let's say, design the layout of flexible manufacturing system, and the process flow looks like that for this flexible manufacturing system process. So we have part feeder. Now you have the feeder where we need anyway some input product. So we have conveying process, then we have storing to the buffer, so we need to introduce racks. Then we have receiving. It means that from the buffer we take it to the production area, this product conveying through conveyor, pick and loading by, let's say, one robot we can use over here. Then we have turning process, unloading and place to the conveyor. Then we have pick and loading by, let's say, second robot, and then the milling process, then unloading and placing of the second by second robot and conveying, and after that it retrieving to the buffer output. So develop a layout of FMS that should follow the above process flow. The system should work in a logical way. It means that it have some kind of storage first, then there are some conveying process, there is some production or machining process, and then it goes back to the storage. So the layout should be put it in such way. It can be from right to left, left to right, is up to you. In the visual component, this is one of the example that we're going to create it actually. So, so it starts from here and goes this way. It can be other way around. It can be different way. So the layout, the design can be different. But the components we use it is automated storage and retrieval system. It's with the cranes and racks, CNC machine, which we use already in machine tending. So that part is already known. I mean, we have done it, how we execute the machine tending with the robot and the machine. This area, this one, I think you are not really familiar in the visual component that we will do. So that's why I have this configuration and simulation of FMS. So we will start with the feeder again, but we need it. We need to create this layout of the storage system, rack, crane, and this controller. So for that purpose, again, there are some components that are listed over here. Main ones are also highlighted from where you can find it. It is in the models by type, e-catalog, PM transport controller, PM cranes, PM warehouse, and what components you need to select it, you can start working on by your own also. Okay, there is some kind of properties change, like some height, because if you have the racks come up always, I don't know, 6 bigger, I mean 6 column or 6 rows or something. So how we can change the properties and make it like 2 by 4. So there are 2 rows and 4 columns. So I mean the properties, I change it here, what they are, you can do it, and how it could be look like. So it's look like that, the setup. So we have crane here, controller, input buffer or input rack, then we have production area with mostly machine tending, and then we have output rack. In the visual components, for the sake of not let's say understanding or for the don't do much complexity, so we should change the name, because if we're going to use it from conveyor tag to conveyor, from conveyor to conveyor, from conveyor to conveyor, so there are too many. So we need to change the name in order to let controller understand that what we are talking about. So from conveyor in, so I change the name over here, from conveyor in, buffer in. So if I connect it this one to this one, so that it will understand that I will go for this buffer, not to this buffer. So anyway, the idea here to change the names of these process tags. So we change it from conveyor in, buffer in, to conveyor in, from conveyor. PL is like the pro lathe and pro mill. So that's how we will do it. And this note is also here, check and change the process name in the process tab. So it can be same like here. Then the flow is quite straightforward. There is no parallel processing, although it could be possible now in the visual component, but the strict flow start from here, from conveyor in, buffer in, to conveyor, then machining processes and controllers, we need to connect it. And then it should work this way here. Now if we have this product coming in, and then it goes to, let's say, storage area first, which is on the rack, and then we have the another conveyor, which is, let's say, the production area side. We have the product moving, which is, let's say, the block, and then first machining, we have, let's say, turning process, we have cylindrical parts outcome. So you will see that it comes out as a cylindrical part, and then now here the shape change are happening also. And then we have this let's say milling process, we have a different shape over there, or milling plus drilling, whatever. And then the part is ready, and then it goes to this let's say the second buffer or storage area. So that is how the cycle of this FMS we're going to execute. Layout, again, it can be this setup different way. You can set up, one setup is like that from the previous work of the students. So this I showed you, you can use your imagination and put the layout in different way. Anyway, it must have some input buffer, output buffer, and some machining processes. And could be handling of the storages could be through this cranes and rack for storage combination. So let's do this FMS in the visual components. What do you think? This one. And then we can continue today or the next class with the machine tending, and I hope you know how to do machine tending, but slides are also there that could help to do this task. So we can start with something with cranes and racks. So let's remove. Okay, I'm just going to clear all. Don't save, and let's move with this. But I start with the scratch, and I will go through this PM flow components and try to have the feeder from there again, and then we start with that, I think. And as I have this feeder, I try to make it 90 degree towards other side. So then I could have conveyors. So we have conveyor 1, and then we can have another conveyor. And first one I just plug in here and see if it's moving, good to go. Same thing, I think it's you also have done it in the previous exercise. So now the other one we can have it with the other side, but okay. Now we need to have it. If you go to this also slide that what I presented, so we have feeder, we have couple of conveyors, but we need let's say stacker, crane, single, and then transport controller and the rack. So this we can find out PM cranes we have, and go to the last, and then we have stacker, crane single, and then PM transport controller. We can go into the last and have this single rail transport controller. And how I can connect it. So let's adjust it a bit here, and let's have this crane and plug in at the top of this controller. So I bring it closer, and again this green arrow you see is appearing, and then I just drop it here, and if it's connected, it goes to the one edge of this controller, and yeah, we bring it a bit closer. Then I need, let's say, rack. So PM warehousing, visual components. Last one, warehouse shelf. So you see, this is the shelf that I have, and I can see it has input and output with these arrows. So it's good to go. But here I can change it, the structure. So it has right now 5 tires, 5 base, so 5 column, 5 row. So let's make it 2 rows and 4 columns. If we can make it, then it's okay. Let's say some changes I can do it in the options. I can click on the shelf, rail. Okay, is good. See, materials, less, color it a bit if you want, then otherwise it can be same, but colors can be changed from here. Yeah. Anyway, not really needed, but the colors can be changed of this placing area here in the materials, default in the materials, and also in the materials tab. Also, if you see in this slide, I have some changes with the length of this single rail transport controller. So I make it track length is 1000. It was 5000, and then it's moved there. But let's move to this near to the first conveyor. Then I need another, let's say, a crane. We can have this stacker crane single again, and then we could have also controller, single rail controller, and just try to place it a bit closer as it was in the slides, or something like here. So I plug in and it's something like that, so that it's close. And then I have another conveyor which I also bring little bit closer to the second stacker crane. So if I play the simulation, you see these parts are coming in. Anyway, there is nothing working in a sense, because there is no input signal, or this process tags are missing. So we need to put it those from conveyor to conveyor process components. And also we need to, let's say, change the shape, but let's first try to connect the flow. And for that we need the process component. So yeah, PM flow component, visual components, and from conveyor. So from conveyor it means that the part will take from conveyor. Then there is process by stacker crane 1, then 2 buffer process, and then 2 conveyor. I can have it to the output conveyor, which is the other side. Now if I go to the process tab, product, I have it, processes, I have, let's say, the 3 again different processes tag, from process, which is the input, buffer is the storage, and this is the output conveyor that takes the product to, let's say, the production cycle. And right now this is transportation. So we have from conveyor, as I say, we can change the name to our understanding. So if I click to this from conveyor, then this window I can close. In the properties I can change the name, let's say from conveyor in. Buffer also we can make it in, and to conveyor also we can have it, or you can make it ABCD also, but yeah. So this is like how the input mechanism working here. Now we need to connect the flow. So if I go to the flow again, I click, and if I would like to have those steps defined directly here, so I just go from conveyor, then I click over here, you see this appears automatically here, and then I move to the buffer and click to the buffer, and from buffer to this to conveyor. Same process flow, I mean the idea is the same as we did it in the machine tending. So if I press the simulation, so parts are coming in and they are just again flying. It means that the controller is not implemented. So I click this controller, first one, and then this first flow line and change it. Then the second one, controller, second flow line, play the simulation again, and let's see if these cranes are working or not. So now the crane is taking this product and storing to the storage area, let's say, and then from storage it goes to the production, let's say, area or the output conveyor. So this is how that simple it is, if I hope. But let's have the shape. Right now is cylinder is there. Let's say we would like to have some kind of block. So if I would like to have different shape, I must have that shape defined in this product list, and for that I should have that let's say product shape in this 3D world. And if I go to this models by type, visual components, basic shapes, and visual components, we have this block geo, and then we can have it, let's change the color, and also maybe let's change the size, maybe it's good to go. So now I need to define this product over here. Right now is VC cylinder. If I go there in the product, change the name, let's say block, and then click. Then in the properties, I have the block over here. Then in the properties, it's not visible that much. So if you will have something which is this kind of pick component from 3D world. If I click over here and then select this block geo, and then I select this feeder, in the feeder product creator, if block is appear, which is good, then we try to simulate and see that if the block is appear. So now the products are coming in the form of the blocks. Also the creation is, let's make it 20 second. So now the product is going first to the storage and then is taking out from here. The next steps are, again we have a conveyor line moving on, and then we have machine tending. Machine tending mechanism is the same as we did in the first exercise, and then in the end the output buffer rack is the same as we have input. I hope you grasp the idea. Perhaps it's too much for today and you already feel sleepy or tired, as my guys are. I am also a bit. But anyway, I have a couple of lectures with the visual components, and then I will be available for the consultation later on. So I try to cover as much as possible. So I hope you are okay with that and try to stick with this pace. It is anyway help you in the end for your group work. So if you manage with this thing, is good to go. You can continue by yourself, or in the next lecture I will continue from here. That how we can proceed it with the whole flexible manufacturing system concept or simulation in the visual components. We try to have this license keys actually. So that you can use it at your home. Otherwise, you are welcome here in our computer class to use. But yeah, that's it for today. If you have any question, I am here still about the visual components, anything. So otherwise, we will continue next time from here. Thank you. Yeah.